Welcome to the deep dive. Today we're looking at, well, more than just a planet, aren't we? We're sort of digging into this long-held human fascination, finding another place out there. And nowhere really captures that dream quite like Mars. So our mission today really is to unpack the sources you provided. We want to understand, why Mars is the red planet and what makes its features so extraordinary.
Yeah.
And maybe touch on why it keeps pulling us back, why we're still so curious about it. We're aiming to pull out some surprising facts for you, give you a real handle on our neighbor. Okay, so first things first, everyone knows Mars is red. But why? What's actually going on there?
Right. Well, that classic red color, it comes down to iron oxide, basically rust, just like you'd find here on Earth, but, on a planetary scale.
Rust, okay, like a whole planet just
Exactly.
crusted.
Pretty much. And the science is fascinating. Billions of years back, Mars, it had liquid water, loads of it potentially. And when that water met the iron-rich rocks, lots of silicates in there, it caused oxidation. Hematite mostly. And some think UV radiation might have even sped things up by breaking down water molecules. Then over ages and ages, the Martian winds just whipped this fine red dust all over the place, giving us that reddish tint we see.
Huh. So the red dust is kind of like a record of its past potential, a lost, watery past. Very different from our blue Earth.
But is it all red? Like if you were standing there, would everything just look rusty?
Ah, good question. No, not really. From far away, yes, it's strikingly red. But the close-up pictures, they show a much more varied look. You get big patches of brown, gold, even tan. And here's something really wild. The sources mention the sky.
The sky.
Yeah. During the day, it often looks reddish because of all that dust hanging in the air. But get this, during sunrise and sunset, it can actually turn blue.
Blue. That's the complete opposite of Earth. Our sunsets are red and orange. Exactly. It's a really neat inversion.
Okay, that's fascinating. But Mars isn't just, a pretty color. It's features. They tell an even bigger story, right? Beyond the red, it sounds like it's a planet of extremes.
Oh, absolutely. The sources really pull out 5 standout things that make Mars incredible. First off, and this one just blows my mind every time, is Olympus Mons.
The giant volcano.
The giant volcano, tallest in the whole solar system. It's this massive shield volcano, standing 22 kilometers high. That's 13.6 miles. I mean, think about it. That's almost 3 times the height of Mount Everest.
3 times Everest. Wow, that scale is just, hard to grasp.
Yeah.
Does that immense size tell us something specific about how volcanoes worked on Mars compared to here?
It tells us a lot, actually. Its huge size suggests really, really long periods of volcanic activity. It implies the magma source underneath stayed put for an incredibly long time, unlike Earth, where our tectonic plates move things around.
Ah, okay, so no plate tectonics moving the crust over the hotspot.
Exactly. So these volcanoes could just build and build and build. Points to a very active geological past. And then there's Valles Marineris. People call it the Grand Canyon of Mars.
Right, but it makes our Grand Canyon look small, doesn't it?
It really does. This thing isn't just a canyon, it's the biggest canyon system in the solar system. It stretches over 4,000 kilometers. That's 2,500 miles long. So yeah, about 10 times longer and maybe 4 times deeper than our Grand Canyon. It's immense.
Okay, immense.
Yeah.
And if it's that big, maybe tectonics again.
Yeah.
But different from Earth's. How did it form?
That's a really key point. Our Grand Canyon was carved mostly by the Colorado River, right, on an uplifted plateau. Valles Marineris, though, the thinking is it's mainly a massive tectonic rift, like the planet's crust just cracked open.
A giant crack.
A giant crack, yeah. Maybe later widened by erosion and possibly even some ancient water flows contributed too. But its scale points towards a different kind of crustal stress than Earth's plate tectonics, something perhaps more fundamental to early Mars.
You mentioned water flows again there, which I guess leads us right into one of the biggest Martian mysteries, the signs of ancient water. That seems to be everywhere in the discussion.
It really is. And, it's central to why we're so interested, especially for the search for life. The evidence is pretty compelling. We see these ancient riverbeds, dried up lake basins, minerals that only form in water. It all strongly suggests Mars was, warmer and wetter a long time ago.
So not the cold, dry desert we see now.
Not always, no. And what's really exciting now are the more recent discoveries. We've found lots of subsurface ice and maybe even seasonal flows of salty, briny water on some slopes today.
Really? Water now?
Possibly, yeah. Very salty, which helps it stay liquid at low temperatures. It keeps that hope alive, Finding microbial life, maybe hiding out in those little niches. Okay, next up is the extreme weather and climate. Mars isn't exactly pleasant.
Right. I hear the dust storms or something else.
Oh, they're legendary. They can kick up and last for months. Sometimes they grow so big they cover the entire planet in dust.
The whole planet. Wow.
Yeah, and the temperatures can drop to minus 125 Celsius at night. That's minus 195 Fahrenheit. Just incredibly cold.
Yikes. But despite all that, it still has seasons, like Earth.
It does, which is pretty cool. It has an axial tilt, similar to Earth, so it experiences distinct seasons. Adds another layer of, well, complexity to this seemingly harsh world.
Amazing. Okay, so extreme geology, extreme weather. What about its little companions, the moons?
Right. Number 5, Phobos and Deimos, Mars' 2 moons.
They're not round like our moon, are they?
No, not at all. They're small, kind of potato-shaped, irregular. The general idea is they're probably asteroids that got captured by Mars's gravity way back when.
Captured asteroids, okay.
And here's a neat, slightly ominous detail from the sources about Phobos, the inner one.
Oh,
It's actually slowly spiraling inward towards Mars.
seriously. It's going to crash.
Eventually, yeah. The calculations suggest it'll either hit Mars or get torn apart by gravity and form a ring. Probably within the next, say, 50 million years or so.
50 million years?
Yeah.
Okay, not tomorrow then, but still. What a dramatic little system. So we've got this incredible list. Giant volcanoes, vast canyons, signs of past water, crazy weather, doomed moons. What does it all add up to? Why is Mars still such a huge focus for us? Why pour all these resources into exploring it?
That's the big question, isn't it? And I think if you connect all these dots, Mars isn't just, another point of light in the sky. It really represents possibility, curiosity, maybe even our own future. It's like a cosmic mirror in some ways.
A mirror. How so?
Well, first, there's the obvious one, the search for life. It's considered one of the best places in our solar system, maybe the best besides Earth, where life might have existed, probably microbial life back when it was warmer and wetter.
And finding that would be monumental.
Oh, completely game-changing. Finding life that evolved separately from Earth life, that would suggest life isn't some unique fluke, that it might be, common out there. Or even if it shares origins with Earth life, maybe through meteorite exchange. That's still an incredible story about how life spreads. It fundamentally shifts how we see ourselves and the universe.
Okay, the search for life is huge. What else?
Then there's the idea of the future of human colonization. It sounds like science fiction, but people are serious. Earth has challenges, right? Environmental pressures, population. Mars is seen by some as a potential second home, a backup plan, maybe.
Like actually living there.
Yeah. Concepts like terraforming, trying to make Mars more Earth-like, warming it up, thickening the atmosphere, or building habitats underground using Martian resources like water ice. These aren't just dreams anymore. People are actively researching how it could be done.
Wow, that's a huge leap.
It is. And related to that, Mars gives us this amazing window into planetary evolution. Studying how Mars changed helps us understand how any planet evolves. Which brings up big questions like, why did Mars change so drastically? Why did it lose its magnetic field? Why did its atmosphere thin out? Why go from potentially warm and wet to cold and dry?
You know why.
Well, the leading theory is its smaller size. It cooled down faster than Earth. Its core solidified. The magnetic field died.
And the magnetic field was like a shield.
Exactly. Without that shield, the solar wind could just strip away the atmosphere over millions of years. Understanding that process, well, it's potentially a cautionary tale for understanding Earth's own long-term climate future.
A cautionary tale. That's sobering.
It is. And finally, Mars is just the logical next stepping stone for deep space exploration. Going to Mars, living and working there, even temporarily, it's the next giant leap for humans in space. The technologies we develop, the experience we gain, that all paves the way for maybe exploring the outer solar system later on, or, eventually, maybe even aiming for planets around other stars. Mars is kind of the proving ground.
What an incredible picture you've painted. From that iconic rusty color, which isn't even the whole story up close, to those absolutely mind-blowing features, Olympus Mons, Valles Marineris, the hints of ancient water. It really does feel like Mars is this beacon, pulling our curiosity and our ambition. And as you said, technology is moving fast. We've got missions like NASA's Artemis aiming for the moon and Mars, SpaceX's Starship. It feels closer than ever. The sources really drive home that feeling, don't they? It's not really a question of if we'll get humans to Mars anymore. It feels much more like a question of when. And maybe the real question for all of us to think about is, what will that future with humans on Mars actually mean for humanity? What comes next?